Take a picture of it. You're good. Okay, so we're gonna spend the first 15 minutes working on this free response. So go ahead, get started. 15 minutes from now, we'll go over it. You can self-grade how you did on those. Okay, so let's go over free response 11 and 12. So for 11, if P of X equals that, so what value of M does P of 3 equal that? For it, and get there. I'm going to put the rubric up so you can grade yourself. There we go. Okay, so you get 1 point for substituting X incorrectly and for getting the values of G of -5 and G of 1. So G of -5 was 5, G of 1 was 1. And so you correctly substituted in X, 5, and 1. So there's 1 point. Correctly simplified your equation. And then a correct solution of n equals 9. Looks a lot like one on the free response, so I'm trying to grade. So hopefully this one went well. Yes, no? All right, part B. What property of functions does a function have to exhibit in order for the inverse of the function to exist? And explain your reasoning. So 1 point for saying it must be one-to-one function. And 1 point for saying no repeating x or y values. And an explanation. So your x and y values are switched. In order for the inverse to exist, there can be no repeated x values or y values if it's to be a function. Part C, is g of x a one-to-one function? Give a numerical reason for your answer. So the correct answer is it is not a one-to-one function. And the explanation is you have a repeated value of y. You put like the y value of 1 equals or appears twice, that's fine. Just some version of there are repeated values of y. And then part D, does G inverse exist? And explain your reasoning. So it does not exist because it is not a one-to-one function. Okay, free response number 12. Part A, find the value of f of 5 based on this result. What point must exist on the graph of the inverse function and give a reason. So 1 point for getting that f of 5 is 11. 1 point for saying since f of 5 is 11, then the point 11, 5 must be on the graph of the inverse. And a point for saying for every point xy on the graph of f of x, the point yx must be a point on the inverse. So basically, some kind of reason for that answer. Why did you get that the point 11, 5 must be on the inverse? Doesn't have to be worded exactly like that, but something along those lines. Okay, part B, after investigating the operations contained in the equations g of x and h of x, why would Jeff claim that either equation could be the inverse of f of x? And be specific in your response. So f of x contains the operations of multiplying by 2 and adding 1. And Jeff might think that both of those could be inverse functions because they both contain dividing by 2 and subtracting 1, which are the inverse operations. So to undo those operations in f of x, you'd have to divide by 2 and subtract 1. And both of the equations, g of x and h of x, do that. Okay, part C, using your value of f of 5 from part A, show and explain why h of x cannot be the inverse function. So you'd get a point for saying since f of 5 is 11, then h of 11 should equal 5 if it's the inverse. And a point for correctly showing that that does not happen. That you get 4.5 instead of 5. And then last but certainly not least, using your value of f of 5, show and explain why g of x is the inverse function of f of x. So just like part C, you get a point for saying since f of 5 is 11, then g of 11 should be 5. And then you show that g of 11 is actually 5. So I'm not going to collect these. I'm not going to grade them. That was just practice for you to remember what we talked about last time. Kind of remember it in your head because we're about to extend our knowledge about graphs a lot. So you can go ahead and put those away and then grab these day 14 notes about periodic functions. Okay, so first up is a periodic function. Which is a function whose y values repeat in a pattern at regular intervals of x values. So if you flip through this notes packet, you'll see lots of really crazy graphs, but all of those graphs, not all of them, most of them repeat on a normal interval. Okay, so they look a little scary, but that's all right. They're just periodic. The period of the function is the length along the x-axis before your pattern of y values begins to repeat. And the amplitude of your graph is half of the distance between the maximum and the minimum y values. So the period is talking about your x values left to right. Your amplitude is talking about half of your height of the graph. Okay, so on this first one, we're trying to determine if the function is periodic, and if not, we want to give a reason. Okay, so remember that periodic means that it repeats every few x values, right? Does that happen on this one? It does. So I'm going to take this marker, and I'm going to trace one period, or one cycle of this weird function. So it is periodic because the y values repeat in a pattern every 4 x values. So from -5 to -1 is 1. And then the next 4, it repeats. And then you can see if you went 4 more, it would repeat again. That's why it does every 4 x values. So if this periodic function just repeats forever and ever, what's going to be my domain? What? It goes on forever and ever? It's going to be negative infinity to positive infinity. It will just keep repeating in both directions forever. Okay, so let's remember that range talks about y values from your least to greatest or bottom to top, right? So what's my least, my smallest y value? -3 up to +3. And those are included because it actually touches those points. Okay, we said that this repeats every how many x values? 4, so it has a period of 4. Okay, and then amplitude was half the distance between the minimum and the maximum y values, right? So my minimum y value is -3. My maximum y value is +3. What's the distance between -3 and +3? 6, and half of that is 3. So I have an amplitude of 3. Okay. On our next one, we want to know, is this function periodic? So I'm going to let you look at it and try to decide for yourself. Is it periodic? Does it repeat on a specific number of x values? Okay, what do you think, yes or no? It's kind of hard to tell, but if we look at starting right here, goes up, down, and has this little one. And if this were to continue going, it looks like it would follow that same pattern, right? So we're going to say, yes, it's periodic, because we're going to assume that it repeats. I should that. Every 1, 2, 3, 4, 5, 6. So here's my start and finish. And it's going to repeat every 6 x values. Okay, again, if it's going to repeat every 6 x values forever and ever in both directions, my domain is going to be negative infinity to positive infinity. What's going to be the range this time? I know you know it. Yes.
-2 to brackets.
Yep, -2 to +2 with brackets, because it's included. What's going to be the period? We already said it. 6. And then the amplitude, remember, is half the distance between the smallest and the largest y value. So between -2 and +2, there's 4 boxes, right? 4 numbers. Half of that would be 2. So your amplitude is 2. Okay, on this next one, when I worked it, I tried to go too fast, and so I didn't really pay attention. And I got the period wrong on this one. So it is periodic, because it repeats. It very clearly repeats forever and ever. But how many x values is it from one to the next? It changes.
Looks like it. Small difference.
So if it starts here, okay, when I looked at it, I just said it was 3. But if you look really closely at your paper, it's actually a little bit more than 3. Because if you go 3 from here, then it's a little bit further. So they call it about 3.1. Okay, again, your domain, if it's repeating, if it's periodic, it's going to be negative infinity to positive infinity. The range, what's your smallest y value? Make you talk to me. What's your smallest y value? -2, and your greatest y value? 4. So it's -2 to 4 included. We already said the period was about 3.1. What's going to be my amplitude?
3.
Yep. Between -2 and 4 are 6 numbers. Half of that is 3. Okay, so the next one. Is this one periodic? Seen some people say no. Why are you saying no? What's different on this one that didn't happen on the last one? Yes.
It's getting bigger every time.
Yes, your Y values are changing. It's getting taller with every time something, your X values repeat. So it is not periodic because the Y values don't repeat in a pattern. Okay, that last one on the page I'm going to let you do without me. If you haven't already, go ahead. Okay, so is this periodic? Yes or no? You can just nod your head, that way you don't have to talk. Yes, it's periodic because it repeats every 6 X values. Your domain, again, is negative infinity to positive infinity. Your range goes from -3 to +3. Has a period of 6, like we've said, and an amplitude of 3. Feeling okay about this so far? Good. Okay, so the table below shows values of one cycle of a periodic function. The graph consists of straight line segments that connect the consecutive points in the table. So based on the values in the table, explain how you know that this is one cycle of a continuous function. Continuous periodic function, sorry. Okay, so I see some of you writing. Hopefully you're writing that the table begins and ends with the same Y value. So if you noticed on all of those that we did earlier, each one cycle started and ended in the same spot. So that's how you know it can be one cycle of a continuous periodic function. Okay, then I want you, without the graph below, so don't graph these points yet, identify the period and the amplitude of the graph and justify your answers. Okay, so does the period come from your x values or your y values? Period is talking about your x values. So how many x values are between -4 and 3? 7 of them. Yep, 7 of them. Okay, amplitude, does that come from your x values or y values? Y values. And it's from your smallest one to your largest one? So it's 6?
No, 3.
3, how'd you get 3?
After.
Half of 6. Okay, part C says sketch a graph of f of x on the interval from -11 to +10. So they've given you the points for one cycle. You're going to graph multiple cycles. So go ahead and do that on part C. Take those points from your table and plot multiple cycles. So hopefully yours looks something like mine. Your original one, I put mine in blue. It's just going to repeat forever and ever in both directions. So part D says, what are the values of f of 15 and f of -77? Is an x value of 15 on my graph?
No.
No. Okay, so I can't just look at the graph and do it. They didn't give me an equation. to plug it into. So I have to use what I know about this function. What do I know is gonna happen forever and ever in both directions? It's gonna repeat, right? How often does it repeat?
77.
Every 7 x values, right? So if I'm talking about f of 15, what's 7 back from 15? Or 15 minus 7?
8.
F of 8, right? So I can look at my graph right here, find f of 8 is -2. And I know that in 7 values, it's going to be the same, right? So I know that f of 15 is also going to be -2. Okay, this is the part that's going to stretch your brain a little bit. F of -77. Anybody have any ideas of a number I can look at?
7.
What about 7?
No. You're going to replace 7. Like we did.
Why?
Because 7 times 11 is 77.
Mm-hmm. Yep, so 11 cycles back at -77. Or I guess I should say 11 cycles backwards would be -77. But that would be 11 cycles from where? Not 7. Wouldn't it be from 0? Because you're going in cycles of 7, so you have 0, and then -7, and -14, all the way back from -77.
No, you get the zero value.
Yeah.
That's the X value.
Your x value is 0. So what's your y value?
2.
2. Okay, I'm gonna click forward to show you how I wrote that on my paper. It's probably gonna be really ugly because I have all this right there. Just ignore the graph in the middle. Okay, so to find f of 15, we did -7 to get it on our graph. I did -14 to get it close to 0. Okay, you're basically just subtracting or adding a multiple of 7 because your period is 7 on your graph. So for -77, if we add 77, that gives you an x value of 0. You could have also used 7, just would have been different there. You would still get a value of 2. So that's how you can write it down algebraically if that's your thing. So I want you to try part E, where you find f of 64 and f of -25. So there's not just one right answer here. There's not just one right way to get to the answer, I should say. F of 64 should be -2. Okay, so I did a multiple of 7 that was close to 64. So I did 7 times 9, which is 63. 64 minus 63 is 1. My value at 1 is -2. Okay, you could have chosen a different value to multiply 7 by to get close to 64. You may have done 7 times 10. So then you would look at -6 to see what your y value is at -6. Should be -2. No one looking at me like I'm crazy.
No, I'm just confused.
Confused? This is hard for me too, so don't feel bad. Okay? This will help when I
The
write.
value is 24 on 7.
Yeah.
That's not right. Just ignore that right there. Goodness. Good call. Okay. I did 28. Where did I get 24? It should be 21. Yeah. My bad. That was on me. Okay. So to find f of a, wherever a may be, determine the closest multiple of the period to that value. Then add or subtract that number to or from a to find which original x value that corresponds with. I have 21 on my paper. Okay, so those are all the notes we're going to do for today. So you get the rest of the time, which is a lot of time. You get like 40 minutes to work on your homework. And, yep, work on your homework. Oh, after lunch, we'll go over the quiz from last time. Don't let me forget. Okay, so you're just doing the day 14 homework, which I think is pink.